Algebra 1, lesson number 51, graphs of linear equations, graphs of vertical and horizontal lines. Now, one of the things that we had talked about in the last lesson, lesson 50, is if I gave you an equation like y equals 2x plus 4, just as a reminder here, the first variable is a independent variable, and the y value is the dependent variable, meaning you can put any number in the whole wide world you want in for x, and when you multiply it by 2 and add it to 4, it's going to spit out a y. That's called a function, actually. Whenever you take this and put a number in here, you do the function of multiplying it by 2 and adding it to 4, and you get a number based on whatever the x is. Alright, so what we're going to do now is look at equations like this, and one of the things I want you to notice, there are no exponents. You've got an exponent of 1 here and an exponent of 1 here. When there are no exponents at all, it's called a linear equation, because when you draw a picture of this equation, you get a straight line. Always, whenever you do not have an exponent except 1 on the x or the y, you get what's called a linear equation, which means when you graph all of the possible answers for x and y, you will get a straight line. So actually what I say is it's drawing a picture of that equation, and it will give you a straight line. So let's get a graph on here. Alright, so there's my graph, and remember I had my little xy table in the last lesson. And let's say we put a 0 in here for x. If we put a 0 in here, what do we get for a y value? 0 times 2 is 0, plus 4 is 4. So when x is 0, y is 4. When x is negative 1, what do we get? Y equals 2 times negative 1 plus 4. So y equals negative 2 plus 4, y equals 2. So when x is negative 1, y equals 2. Alright, we do that for any points we want, usually 3. And I usually pick 0, a negative number, and then a positive number. Now let's not use 4. 4 is getting a little bit too big. Let's use 2. So when x is 2, we get y equals 2 times x is 2 plus 4. So y equals 8. Okay, so this is just like the one we did from lesson number 50. Alright, so now we're going to graph that. And according to the rule, because it's a linear equation, we are going to get a straight line. So we graph 0, 4. So we go left to right 0 and up 4. And the next one, x is negative 1, and we go up 2. So we're right there. So we went over to the left 1 because it's negative and up 2. And the third point, we go over to the right because it's positive 2 and up 8. So over 2, let's get a picture. Over 2, up 1, 2, 3, 4, 5, 6, 7, 8. And get that point right there. Now, we can put any numbers we want in here. We can put any numbers we want in here for x. And it doesn't matter. You will get the exact same straight line. It doesn't matter. So when you draw a line that connects all these dots, you get a straight line that looks like that. That is the picture of that equation. And that's what we're doing here, is drawing a picture, graphing a linear equation, and that's all there is to it. Find 3 points and you end up getting what you need there. Alright, so let's do a few more of these just to kind of get you in the groove as far as how these linear equations work. Let's look at an equation such as y equals, this is example 51.2 at the bottom of page 206, negative 1/2 x plus 2. Yuck, we have a stinking fraction. Okay, so what we do with that is we just come up for numbers for x. So let's use 0. Let's use negative 2, and let's use 2. Now, why did I pick negative 2 and 2? Well, because there's a 2 here. Okay, if you have a 2 in the denominator, I would pick a negative 2 and a 2 here, because then it makes the fraction go away. Alright, so let's put 0 in. Y equals negative 1/2 times 0 plus 2. Well, negative 1/2 times 0 is 0, so y equals 2. Okay. Let's keep going here. Y equals negative 1/2, and this time we're going to put in negative 2. Negative 2 plus 2. So 1/2 of 2 is 1, and a negative is a positive. So my y is 3. So see how the fraction goes away? That's why I use that 2 as my x value. Okay, so let's put in a positive 2. So again, half of 2 is 1, and a negative times a positive is a negative. So y equals negative 1 plus 2, which is 1. Alright, so I know if I did this right, I can tell if I did this right because when I graph these 3 points and I connect the dots, I should get a straight line. So 0, 2, up or down, or left or right 0, up or down, up 2. And the next one I went to the left 2 and up 3. The next one I went over 2 and up 1. So I get myself a straight line right there, so I know I did it right, and there is the graph of negative 1/2 x plus 2. Alright, let's look at a couple more, and then we'll be done here. Alright, so let's get rid of all this stuff. Alright. Sheesh, there's a lot to get rid of. Alright, so now I have, let's see, example 51.3, y equals negative x. Now that one is simpler, but it ends up being a little tricky because it's so simple. Alright, so again, we're just picking 3 numbers for x. Let's put in 2, 0, and negative 2. Then I just grab 3 numbers, doesn't really matter. So, when I put a 2 in there, what do I get? Y equals negative, and I put a 2 in there for x. So y equals negative 2. When x is 0, y equals negative, and then x is going to be 0. So y is 0 because there's no such thing as a negative 0. And when x is negative 2, negative, and then x is negative 2. 2 negatives give me a positive, so y equals 2. So there's my 3 points. And then I go ahead and graph those. 2, negative 2, left 2, down 2, 0, 0, negative 2, 2. Get myself a straight line there. Okay, and that's all there is to graphing y equals negative x. Alright, so graphs of vertical and negative, or vertical and horizontal lines. I'm trying to erase and talk at the same time. Alright, so if I'm graphing x equals negative 2, there is no y value there. So that means really we don't care about y. So what we do is we go over negative 2 on the line, and really it doesn't matter where that negative 2 is, up or down, you know, we just have negative 2 there. And we don't know what our y is. In fact, y doesn't even exist. So therefore, we get a vertical line that goes through all those points. So whenever you have an x equals negative 2, you go over to the left, negative 2, and draw a straight line up and down. When you have something like x is 4, you go over 4, 1, 2, 3, 4, and you draw a vertical line. That's all there is to it. Alright, what if we had something like y equals 4? Well, what does y mean? Y means we go up or down. So we go up 4, and then we draw a straight line across this way. So a y equals 4, when we don't have an x, we get a horizontal line. When x equals 4, and we don't have a y, we get a vertical line, okay, at that point. And that's pretty much all there is to it. Now sometimes they will give you, in fact in the one example that they give us, example 51.6, they say graph y equals 2x and y equals 2 on the same rectangular coordinate system. Alright, so let's graph this first one here, my x and my y. And again, I'm just going to put 2, 0, negative 2 here, just because they're easy numbers. So when x is 2, y is 2 times 2 is 4. When x is 0, 2 times 0 is 0. When x is negative 2 times this 2 here is negative 4. Okay, so that gives me the graph, and we'll do this in blue. Over 2, up 4, 0, 0, left 2, down 4, because they're both negative. And I get this line right there. Boy, I'm good at drawing those lines. Now let's graph y equals 2. Now what did I say about y equals 2? When I'm not given an x, I go up 2, because that's what y is, and I get a horizontal line. Okay, so that right there is graphing both equations, and they are equations because they both have equal signs here, on the same coordinate plane. Okay, so that's really all they're asking you to do. If you go to the practice problems, they give you 4 problems. Notice C and D, they're giving you x equals 3, y equals negative 4. So in C, you're going to get a vertical line at 3, and D, you're going to get a horizontal line at negative 4. And A and B, you're just going to get other lines depending on what you put in there for x and y. You're going to get a line. Let's see, any more on lesson 51. 14 and 15 are both, again, very similar to what I did. In fact, they're exactly like what I just did, only, different numbers, different equations there. And that is it for lesson number 51. I think you'll be okay.